For this problem of Newton's second law, and the problem gives us the angle of 40 degrees, mass is 36 kilograms, force is 65 newtons, and your coefficient of kinetic friction is 0.13. All the forces you have acting on is a normal force coming up from the object, the kinetic friction, it's a sliding force. You have the force being pulled by the person, the 40-degree angle, and mass gravity going down. You have the sum of forces in the x direction is equal to mass times acceleration because it's being pulled and there's not a constant. It's not constant. It's not an equilibrium. So the sum of the forces equals normal force plus kinetic friction plus the force being pulled plus mass gravity. So in the x direction, it's equal to mass times acceleration. So in the x, you have negative f of k because it's going the opposite direction. If you have a positive force times cosine, because cosine is adjacent over hypotenuse, and that's you're using your x's. It's equal to mass times acceleration because the acceleration in the x. And then you do sum of forces in your y is equal to 0. There's no acceleration in the y direction. So normal force minus your mass times gravity plus force times sine of theta. Sine because it's opposite over hypotenuse, and you're using your y's. So your normal force is equal to, you can add this to that side and subtract this to the other side. It's going to be like a subtraction symbol in between there. So this times this is 352 newtons because the kilograms cancel out, minus 49 because there's no sine, there's no units for sine of an angle, and you're left with 303 newtons. And that's your normal force. And that's the first part of the problem. That's A. Find the magnitude of the normal force. And then, so the second part of the problem is, can you find the kinetic friction? Well, kinetic friction is the coefficient of kinetic friction times normal force, and gives you that, and you just found normal force, so you can multiply those together, and it's 39 newtons. Part C, what is acceleration if it's put a 65 newton force of 40 degrees? Well, acceleration you can find by coming back up here, and here you have acceleration. You know the mass, you know the force, and now you know the kinetic friction. So you can bring this down here. You divide by the mass to get to the other side. It gives you acceleration on your own, and then you just multiply all those out, or you add those two, and you divide by 36. It gives you 0.3 meters per second. And then on D, it says starting at from rest, how long a time must she pull with a force until the suitcase reaches a comfortable walking speed of 0.5 meters per second. Now, acceleration is the change of velocity over change in time. So if the initial velocity is 0 and the final velocity is 0.5, we know the acceleration because we found it out up here. Then you can set acceleration equals change in velocity over change in time. And then time, you can rearrange this, time equals the change in velocity over the acceleration, which is 1.6 seconds. And that's Newton's second law.